In this video, I will discuss the geometric relationship of angles and lines in the same plane. So here in the given diagram, what we have here is, so we have line A and line B. So line A and line B are parallel to each other, and it is cut by another line which is called line C, and this is a transversal line. And what we see here is, when we have something like this happening, so we get 8 angles made. So we have 1 angle, 2 angle, 3 angle, 4 angle, 5, 6, 7, 8. So 8 angles are formed in this situation. So just so that you know, we have parallel lines A and B, and they're cut by a third line which is called transversal line C. So this is the terminology that we're going to use. So in this case, 8 angles are formed, and if you in these 8 angles, there are few interior angles and few exterior angles. So as the name suggests, interior angle means the angles which are formed inside the parallel lines. So these are interior angles. So in this case, interior angles would be angle 3, angle 4, angle 5, and angle 6, because they are formed inside the lines, so by the transversal line. And similarly, we have another set of angles here which are called exterior angles. So in this case, we have angle 1, angle 2, angle 8, angle 7. So we have exterior angles. So exterior angles are angle 1, angle 2, angle 7, and angle 8. I have removed the extra angle drawing so that when we talk about the different pairs of angles, that I can just show you by highlighting those. So first we're going to talk about a special pair of angles whose name is vertical opposite angles, or just opposite angles. So when two straight lines intersect with each other, so they form 4 angles. So let's just take a look at, if we have two lines that intersect each other, so the opposite angles are the angles which are formed here. And similarly, there is another pair of opposite angle that would be this one. So opposite angles are always equal. So in the given diagram, we can look at the opposite angles. So in this case, the opposite angles would be, so you can take a moment to think about the opposite angle. So here we have angle 1 and angle 3. So that form opposite angles. Angle 1, angle 3. Another pair of opposite angles would be, so angle 2 and angle 4. Similarly, we have pairs of opposite angles in here. So angle 5 is equal to angle 7, and similarly we have angle 6 equals to angle 8. So these are vertical opposite angles and they are equal. Vertical opposite angles are equal. So here angle 1 is equal to angle 3, angle 2 equal to angle 4, and so on. So next we're going to talk about our corresponding angles. So whenever we have two parallel lines which are cut by a transversal line. So we already talked about exterior and interior angles, but if the angles are at exact same location, so for example, we can talk about this angle here and this angle here. So they are called the corresponding angles. So they are on the same side of the line and they are at the corresponding position. So above the line 1, above the line 2. So above line A, above line B, and also on the same side. So same side, exact same position. So these are called corresponding angles. So now we're going to look in our shape for the corresponding angles. So in this case, we have angle 1 equals to angle 5. So these are the pair of corresponding angles. So angle 1 and angle 5. Another pair of corresponding angles would be angle 2, angle 6. Another pair of corresponding angles would be angle 4, angle 8. So again, so exact same location. So on the same side of the transversal line, and if this one is below the line, so angle 8 is also below the parallel line. So similarly, we have the last one. Angle 3 should be equal to angle 7, and these are our corresponding angle. So all the corresponding angles are equal. So as the name suggests, alternate, so it means they are on the alternate sides of the transversal and they are the interior angle. So if you remember, we talked in the beginning that these are the interior angles. So we are talking about alternate on the alternate sides of the transversal, but formed between the parallel lines. So inside. So in this case, if we look at the diagram, so our angle 4 should be equal to angle 6. So this is a pair of alternate interior angle. Similarly, another pair of alternate interior angles would be angle 3 should be equal to angle 5. So angle 3 and angle 5. Another pair of equal angles that we have are called alternate exterior angles. So in this case, as the name suggests, they are on the alternate sides of the transversal. So these would be on the alternate sides, but exterior, outside of the parallel line. So alternate exterior angles. So looking at the diagram here, so we have angle 1 and angle 7, which form the alternate exterior angle pairs. Another pair would be angle 2 and angle 8. Again, alternate exterior angles are always equal. So all these four pairs of angles that we just discussed, they have an important property that they have equal measure. Right, so there are a few other things that we can discuss about the angles. So just recall that if you have something like this, it is a corner angle and 90-degree angle is called right angle. Similarly, if you have a straight line and we say that, so what would be the measure of this angle? So this angle measure would be 180 degree. So angle on a straight line is called measures 180 degrees. So straight angle. Alright, so let's take a moment and try to apply all this information that we just learned in order to solve the next problem. So given in the above diagram, angle 1 is equal to 40 degrees, find all the other angles. So I have already redrawn the diagram here. So what we are given here is, so given angle 1 is equal to 40 degrees, and we have to find all the other angles. All right, so angle 1 is 40 degrees. So what can we say about angle 2? So what will be angle 2? And you can easily see that angle 1 and angle 2, they are on a straight line. So since angle 1 plus angle 2 are on a straight line, so the sum should be 180 degrees. So from here we get angle 2 should be 180 degree minus the measure of angle 1, which is 40 degrees. So we get angle 2 is equal to 140 degrees. So far we already found that angle 1 is 40 degrees, angle 2 is 140 degrees. Alright, so now we can think about our opposite angles since we already know the two angles here. So using the concept of opposite angles, we can see that angle 3 would be same as angle 1, which would be 40 degrees, and angle 4 and angle 2 have the same measure because again they are opposite angles. So it's always a good idea to know the reasoning where you get the angle measure from. So now let's talk about angle 1 and angle 5. So angle 5 and angle 1 are equal because they are on the same side of the transversal and they are at the corresponding positions above the parallel lines. So angle 5 is equal to angle 1 and the measure of angle 5 would be 40 degrees. So these are corresponding angles. Similarly, we can think about angle 6 and angle 4. So angle 6 and angle 4. So these are on the alternate sides and interior of the parallel lines. So these angles are called alternate interior angles. So angle 6 is equal to angle 4 and the measure would be 140 degrees because alternate interior angles. Alternate interior angles. And now we have the values of angle 5 and angle 6. So angle 7 and angle 8 is easier to find now because we can clearly see that angle 7 is going to be same as angle 5, which is equals to 40 degree. Similarly, angle 8 and angle 6 going to have the same measure, which is 140 degree because these are the pair of opposite angles. So we were able to figure out all the angles, missing angles, using our information about the pair of angles. Let's try to solve another example in which we can use the information about the relationship of different angles. So a plumber wishes to add a pipe parallel to an existing pipeline as shown in the picture here. So we need to figure out the measure of angle X. So I can just redraw this diagram so that we can work with the new version. So basically we have a line here and then we have another line. So it shows our two parallel pipes and then they are joined by a pipe in the middle. So this angle is given to be 32 degrees. This angle is X, so this is what we're going to try to find. and I can just extend the pipe above as well. So let's call this angle A. And our goal is to find angle X. So goal is to find angle X. So I want you to take a moment and think about the relationship between angle A and X. So we can clearly think that angle A and X, the sum of those would be 180 degrees because they are angles on a straight line. So it means if somehow we can find angle A, we can figure out the value of X. So for angle A and angle 32 degrees, so we know that, so two pipes, so this is our line 1, line 2, so pipe 1 and pipe 2, so they are parallel to each other, and this is our transversal line. So you can just visualize, extend it a little bit and visualize this as a transversal line. So now we can see that angle A and 32 degrees, they are on the alternate sides of our transversal line, and they are the interior angles. So from here we got angle A is equal to 32 degrees because they are alternate interior angles. Interior angles. So now we know the value of angle A. So from here we got 32 degrees plus x is equal to 180 degrees, and our x would be 180 degrees minus 32 degrees. So our x would be 148 degrees. So the measure of the missing angle x is 148 degrees. Thanks for watching. So please do watch the next video in which we will learn about polygons.